Before we start number 11, I want to show you number 8. So we'll do that one first. We want to solve sine of 2x. Sine of x equals cosine of x. And for these equations, it just says to solve, so we're going to have to consider multiple rotations around the unit circle. Okay. You might be thinking there's different ways to solve this equation, and there very well could be. So some of you might be thinking of dividing both sides by cosine x. Yeah, that might work. But remember, if you're going to be setting factors equal to anything, you have to set them equal to 0. So if I go ahead and move this over, and now I have it set equal to 0, am I able to factor? That is certainly one of the techniques we've used a lot with solving equations. Right now I don't see anything that I can factor out. So what I want to do is consider taking out the sine of 2x, and I want to replace it with its identity. So the sine of 2x is 2 sine x cosine x. Okay? And so what we're going to do is put that in for sine of 2x, and then we have to multiply that by sine of x. And here's the rest of our equation. All right, I'm going to clean that up. All right, now I think you guys can all see that we have a cosine x that we can factor out. From here, we can solve and set each factor equal to 0. All right, so where is cosine equal to 0? Cosine is equal to 0 at pi over 2 and 3 pi over 2. Those are pi apart, so pi over 2 plus n pi. Sine of x is equal to positive 1 over radical 2 at pi over 4 and 3 pi over 4. It's equal to negative 1 over the square root of 2 at 5 pi over 4 and 7 pi over 4. These two are 180 degrees apart, and so are these two. So, in fact, they're all 90 degrees apart. So I think I'll just shortcut all that and add 90 degrees to each. All right, when we try 11, it's the sine of 4x equals the negative 2 sine of 2x. So the sine of 4x, we know that the sine of 2 theta is 2 sine x cosine x. Well, if this is 4x, our theta is actually going to be 2x. So the sine of 4x would be 2 sine of 2x cosine of 2x. Now I'm going to leave it like that for a little bit. I'm just going to add my sine of 2x over. Now I could use identities to change all of these out of double angles into single angles, but I don't need to. Watch what I can do. I can go ahead and factor out 2 sine of 2x. I can set my factors equal to 0. I can go ahead and divide by 2 here. And now I can start solving each equation. So we did a little bit of this work with the double angles in lesson 5.3. So we're going to go back and revisit this. Sine is 0 at 0 and pi. So I'm going to have 2x, though, not x. 2x equals 0 and pi. Well, they're pi apart, so 2x equals 0 plus n pi. Divide by 2 at the very end. I get n pi over 2. Cosine is -1 at pi. And I would have to add, let's see here, get back to that. So 2n pi, or let's see, 2 pi, yeah, that was right, 2n pi to that. To add 360 all the way around. So I'm going to divide by 2. So that's pi over 2 plus n pi. That's actually going to end up being the same thing as this, because right here, if n is 0, I have pi over 2. If n is 1, I have 3 pi over 2, and so on. Everything here, everything I can generate here can be generated in this one. So this is going to be my answer. All right. We're also going to look at a few problems such as this, number 16 and 17. So you just need to rewrite these using a double angle identity. All right. Sine x, cosine x. What is that in terms of a double angle identity? Well, we know that the sine of 2x is 2 sine x cosine x. Okay, so what we could do here is divide by 2, and then we would have 1/2 sine of 2x equals sine x cosine x. All right, so I would argue that this is 1/2 sine of 2x. What about number 17? I see that they both have a 3 in common. Okay, so I'm going to go back to my double angles. And let's see here. Looking at all those formulas we came up with today, this is the same as the cosine of 2x. So I would argue that this is 3 cosine of 2x. So you're just manipulating formulas. Okay. I hope this works for you guys, takes care of double angles. We'll go on and catch power reducing and half angles in the next part of our lesson.